Welcome to Bhardwaj Gurukul. Today's chemistry lesson is all about one of the most powerful tools in science, the periodic table. So if you are new to this channel, don't forget to like, subscribe and share this video with your friends. From hydrogen to oganesson, this chart holds the key to understanding the behavior of all the elements. Laws of motion chapter from physics class 9th explained link in I button. If you are new here, don't forget to like and subscribe. So in this video, we learn the element arrangement by atomic number, what are groups and what are periods, periodic properties like atomic size, ionization potential, electron affinity, electronegativity, reactivity, metallic and non-metallic character. So the key focus would be on the groups 1st, 2nd, 13th, 14th, 15th, 16th, 17th and 18 as they are included in the syllabus.
Chapter Periodic Properties. So in class 9 we have already read about Dobrnius triad and Newland's law of octave, which were proved to be wrong. So now let's study about the correct laws which are included in the modern periodic table. So Mendeleev's periodic table. The physical and chemical properties of the elements are the periodic function of their atomic mass. So मेंडलीव ने हमें बताया कि जो फिजिकल और केमिकल प्रॉपर्टीज एलिमेंट्स की होती हैं वो एटॉमिक मास पे डिपेंड करती हैं. फिर उसके बाद आई मॉडर्न पीरियोडिक टेबल विच वॉज गिवन बाय हेनरी मोसले. The physical and chemical properties of the elements are the periodic function of their atomic number. So the difference between Mendeleev's periodic table and modern periodic table is only this much, that Mendeleev talked about the atomic mass and Henry Moseley talked about the atomic number. So now let's talk about some characteristics of the periodic table. There are 18 vertical columns in the periodic table called groups. So the vertical columns which are provided in the periodic table, they are called groups and they are 18 in number. There are 7 horizontal rows called periods. So there are 7 rows horizontal, they are 7 in number and they are called as periods. First element of each period is always an alkaline metal and the last element is a noble gas. So this you have to remember, this is an important point, that first element in every horizontal row is an alkaline metal. The second one is the alkaline earth metal, which we will discuss later, and the last element is always a noble gas. In periodic table, elements are placed in increasing order of atomic number. So if we look in the periodic table, all the elements are arranged in the increasing order of their atomic numbers. So let's talk about the periods, the 7 horizontal groups. So the first period contains maximum 2 elements and this is the very short period. The second one contains 8 and it is called as the short period. The third one contains 8 elements and this is also called as the short period. The fourth and the fifth contain 18 elements each and they both are referred as long periods. The sixth one is containing 32 elements and it is the very long period. This is the longest period in the periodic table. And the seventh one also has 32 elements, but this is still incomplete because many elements in the Earth's crust are still undiscovered. So the periodic table is divided into blocks, which are the S block, P block, D block and F block, but in the syllabus we have only S block and P block, so let's study about them. The S block contains all metals. There is no non-metal, no metalloid. So it has the first group and the second group. This is also referred to as this. And it contains alkali metals and the second group is called as the alkali earth metals because it contains alkali earth metals. The P block contains metals, non-metals and metalloids. It is the only block which contains all the 3 categories. So 13, 14, 15, 16, 17 and 18 are all the group numbers which are contained in the P block. The 15th group is called as nicogens because the first element is nitrogen and so on. The 16th one is called as chalcogens, the 17th one is called halogens and the 18th one are called as noble gases. So let's first talk about the S block elements in the first A. They are all alkali metals: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So the biggest size element is cesium. Francium is not included, but as it is there in the first A group, so I have written it. The valence shell contains one electron, the charge is +1, valency is 1, all elements are metals except hydrogen. So hydrogen is the one non-metal which is contained in the first A group, and the biggest size element in the periodic table are the alkali metals. Now, groups. It is the number of electrons present in valence shell of elements. There are 18 vertical columns in periodic table called groups. If number of valence shell electron is 1 or 2, this is equal to the group number. So now let's have a look at some examples where we'll calculate the group number. So if we look at the first one, it is sodium, and if we do the electronic configuration, we see that the last shell contains one electron. So the group number is 1. Second example, calcium. If we do the electronic configuration, the N shell contains 2 electrons. So the group number is 2. Now, if the number of electrons is valence shell is 3 to 8, if there are more than 2 electrons, then the group number is equal to 10 plus valence shell electron. जो भी valence shell में electron रहेगा plus 10. So now let's look at some examples. Carbon. The last shell contains 4 electrons, so 10 plus 4, so group number is 14. Phosphorus. The last shell contains 5 electrons, so group number is 15. Now periods. It is equal to the number of shells. Example, aluminium. If we do the electronic configuration, we see that 3 shells are there, so the period number is 3rd. In carbon, there are 2 shells, so period number is 2. In calcium, there are 4 shells in which electrons are distributed, so the period number is 4. In sodium, 3 shells are there, so the period number is 3. Now we will talk about the periodic properties like atomic radius, ionization energy or enthalpy or potential. So these all are the terms which are given in paper which might confuse you, so you have to remember them. Electron gain enthalpy or electron affinity, electronegativity and reducing property. And we will also learn about reactivity and metallic property. So first let's talk about atomic radius. It is the distance from nucleus of an atom to the outermost shell or valence shell of an electron. Atomic size in group. As we move from top to bottom in a group, atomic size increases. So from top to bottom in a group, atomic size increases. Why? Because number of shell increases. So this is the increasing order in the first A group. As you can see, the topmost element is smaller and the bottom one is bigger. So now let's talk about the atomic size in periods. As we move from left to right in a period, atomic size decreases. It was increasing when we move from top to bottom, and as we move from left to right, it is decreasing because nuclear charge is increasing. So as you can see, this is the second period in which the elements have their decreasing order. So bigger size, more nuclear charge, smaller size, less nuclear charge. The atomic size of noble gases is slightly bigger than halogens. So the atomic size of noble gases, the 18th group elements, they are bigger than the halogens, means the 17th group elements. Why? Noble gases have van der Waals radius which are slightly bigger than covalent radius because van der Waals force of attraction are weaker. Now let's talk about size of cation. Cations are smaller than parent atom or neutral atom because cations have more nuclear charge. Now let's talk about size of anion. Anions are bigger than parent atom because they have less nuclear charge. Example, Cl negative is greater than Cl neutral. Bigger size because it has less nuclear charge. Now let's talk about ionization energy or enthalpy or ionization potential. It is the amount of energy required to withdraw electron from gaseous isolated atom. So gaseous isolated atom is the key word. The unit is joule per atom and it is denoted by IE or IP. So what is successive ionization energy? It is the amount of energy required to withdraw more than one electron from gaseous isolated atom. Meaning एक इलेक्ट्रॉन निकाल लिया तो आयनाइजेशन एनर्जी बोलेंगे उसको जब दूसरा इलेक्ट्रॉन या फिर तीसरा उसके आगे जितने भी इलेक्ट्रॉन्स निकालेंगे हम लोग, तो उसको हम लोग सक्सेसिव आयनाइजेशन एनर्जी बोलेंगे। नाउ आयनाइजेशन एनर्जी इन अ ग्रुप, top to bottom in a group ionization energy decreases because atomic size decreases. So group में ionization energy always decreases because atomic size increases. So top, smaller size, more energy required to withdraw electrons, so more ionization energy. Bigger size, less energy required to withdraw electron, less ionization energy. Ionization energy in periods. Left to right in a period, ionization energy increases because atomic size decreases and nuclear charge increases. So in a group it always decreases and in the period it always increases. So here's the increasing order of ionization energy in period 2. So now let's talk about some important points. Noble gases have highest ionization energy in periodic table because they have complete octet required more energy to withdraw electron. नोबल गैसेस के पास उनकी वैलेंस शेल में कंप्लीट इलेक्ट्रॉन्स होते हैं 8। अगर हम लोग इलेक्ट्रॉनिक कॉन्फ़िगरेशन करके देखें तो अगर किसी एटम को इलेक्ट्रॉन चाहिए नोबल गैस है तो उसमें मोर एनर्जी रिक्वायर्ड होती है, इसीलिए इनकी हाईएस्ट आयनाइजेशन एनर्जी होती है। Helium has the highest ionization energy in periodic table. Second ionization energy is greater than first ionization energy because in second ionization energy electron withdraw from cation which have more nuclear charge. So successive ionization energy is always greater than the normal ionization energy. Now let's talk about electron gain enthalpy or electron affinity. It is the amount of energy released when electron is gained by a gaseous isolated atom. Gaseous isolated atom is the keyword, and electron gain enthalpy and ionization energy are opposite to each other, but they have the same unit, that is joule per atom, and the same symbol. Electron gain enthalpy in a group. Top to bottom in a group, electron affinity decreases because atomic size increases. So this is the correct sequence, this is the wrong one given. Decreasing order of electron gain enthalpy, it always decreases when we are moving from top to bottom, that is we are moving in a group. Electron gain enthalpy in a period. Left to right in a period, electron affinity increases because atomic size increases. So always when we move from left to right in a period, electron affinity increases. Noble gases have zero electron gain enthalpy because they have complete octet, they never gain electron. So as we discussed earlier that their last shell has complete electrons, so they do not require any more electrons, so they have zero electron gain enthalpy. Electron gain enthalpy of chlorine is greater than fluorine. Give reason. So the electron gain enthalpy of chlorine is greater than fluorine, although we discussed that from top to bottom it always decreases, but fluorine has more than chlorine. Why? Fluorine has the smallest size in periodic table, that's why it has high electron density and causes repulsion, hence a few amount of energy is required, but chlorine has less electron density, that's why chlorine has greater electron affinity than fluorine. Halogens have highest electron affinity in periodic table. Give reason. Because of smaller size. So halogens are the smaller size elements in the whole periodic table, so that's why they have the highest electron affinity. Now let's talk about electronegativity. It is the tendency of an element to attract shared pair electron towards itself. Electronegativity in groups. Top to bottom in a group, electronegativity decreases because atomic size increases. So from top to bottom, electronegativity also decreases. So decreasing order of electronegativity is given. Halogens are the highest electronegative elements in periodic table because of smaller size. Again, they are the smaller size, so they have the highest electronegativity. Electronegativity in periods. Left to right in a period, electronegativity increases because atomic size decreases. So this is the increasing order of electronegativity given. Now let's talk about metallic and non-metallic character. So bigger size, more metallic, and smaller size, more non-metallic. So if the element is more metallic, then it is of the bigger size. So as we know that the starting elements are of bigger size and the last ones like halogens, they are the smallest. So the halogens are less metallic or more non-metallic, and the bigger size elements are more metallic and less non-metallic. So the between one elements may be called as metalloids. Let's talk about reducing property. Bigger size more reducing because they lose electrons easily. So as we know that bigger size are more metallic, so metals are reducing agents because they lose electron easily. Oxidizing properties, smaller size more oxidizing because they gain electrons easily like nonmetals. Chemical reactivity, elements have tendency to lose electron easily are called more reactive. Elements that have tendency to gain electron easily are called more reactive. Meaning that all the elements are reactive means the starting elements are also very reactive and the last elements are also very reactive. Now let's talk about chemical reactivity in groups for metals. So top to bottom in a group for metals, reactivity increases because tendency to lose electron increases due to bigger size. So as the losing of electron tendency increases, so they become more reactive. For non-metals, top to bottom in a group, chemical reactivity of non-metals decreases because tendency to gain electron decreases due to bigger atomic size. As atomic size increases, metallic character increases, so the non-metallic character decreases. Now chemical reactivity in periods. Chemical reactivity in a period first decreases and then increases. So if we look at the second period, bigger size elements lose electrons, so they are more reactive. First reactivity decreases and then it increases. Smaller size gain electron, more reactive. So as you can see, after carbon the reactivity is increasing and before carbon it is decreasing.
Summary and exam tips. Periodic table, element arrangement by atomic number, groups, vertical, periods, horizontal, known trends like size, reactivity, metallic character, focus on key groups like 1st, 2nd, 13th, 14th, 15th, 16th, 17th, and 18th. Tip. Make your own periodic table chart, stick it near your study desk so that you can memorize it. That's all for today's journey through the periodic table. If this video helped you, give it a like, share it with your friends, and subscribe to Bhardwaj Gurukul for more ICSE Class 10 Science made simple. Thanks for watching.